So, I'm going to start explaining the topic of energy in physics, and we're going to go through it together, slowly, step by step. So, when we're talking about energy, there are different forms of energy. So, over here it says energy enables work to be done, and people and machines need a supply of it. It exists in many forms. Now, these are all the different forms of energy. Now, starting from potential energy, there are three different kinds of potential energy. You have elastic potential energy, gravitational potential energy, and chemical potential energy. Now, starting with elastic potential energy. When you see elastic, your mind might go to a rubber band, for example, and this is what elastic potential energy is. So when you stretch a rubber band, when you see that tension, this means that there is elastic potential energy. So energy is stored in that stretching. So with a rubber band, when you stretch it, the potential energy is stored. The elastic potential energy is stored in the rubber band because you are stretching it. Now, another form of potential energy. So first you have elastic potential energy, and now another form of potential energy is gravitational potential energy. So this basically means every time there's an object on the table, for example, or you're holding an object, there is gravity trying to pull it down. So over here it says objects which are raised above the ground have stored energy caused by the force of gravity of the Earth acting on them. So the gravity of the Earth. So when you're holding a controller, for example, and you're playing a game, the gravitational pull is pulling the controller to the ground, but you're holding it. So that's what gravitational potential energy is, when there's something on a surface or you're holding something and it's trying to be pulled down by gravity. Now you have chemical energy. Chemical energy is what you have in, for example, coal, oil, petrol, but also chemical energy can be found in food. So all these things contain potential chemical energy. Now another form of energy is kinetic energy. So it is the energy of movement. So an object which has motion, whether it is vertical or horizontal motion, has kinetic energy. So anything that's moving, a car, even if you're running, even if there's a plane flying, that's using kinetic energy because it is moving. Now we have nuclear energy, energy gained from atoms' nuclei, which is a bit complicated to explain right now. I'll get to it later. Nuclear power plants break open atoms to get the energy within them. Next, you have heat energy. This is energy that comes from. It is the energy resulting from two objects with different temperatures being close to each other. So if you go next to a heater, for example, you can feel the heat energy from the heater. Or if you go next to a stove while something is cooking, you can feel that heat. So that's what heat energy is. Next, you have electromagnetic radiation, which is light energy. So electromagnetic radiation can travel in a vacuum. For example, X-rays, infrared, ultraviolet, radio waves, and light waves. These are all forms of electromagnetic radiation. Now you have electrical energy, the energy that you use to power your things like your PlayStation, your TV. This is called electrical energy. Then you have sound energy, which is uh, it basically is vibrations in the air when we speak and when we hear a sound. We're hearing those sounds because the air is vibrating at a certain pitch, we call it, or with certain sound waves. Our ears detect these sound waves. So, for example, loudspeakers and musical instruments produce sound waves. Um, so yes, that's what sound energy is. Then you have magnetic energy, which is energy produced by magnets, of course. This can be felt when you put two magnets next to each other, or when you put a magnet next to iron, for example. The stronger the magnetic force, the stronger the iron is pulled towards the magnet. So now moving on to conservation of energy. What this basically means is, let's read the law of conservation of energy. Energy can neither be created nor destroyed, but can change from one form to another. So when we say conservation of energy, we say when energy changes its form from one type of energy to another. So for example, when you switch when you press a switch to switch on a lamp, for example, the energy from the power station, which provides the electricity, is changed to light energy into the bulb. So that's what conservation of energy means. It changes from one form of energy, which was the electricity generated by the power station, to the light energy, which is in the bulb. There's always useful and wasted energy. Useful energy is when, for example, you light a candle and it creates light energy. The whole point of a candle, of switching on a candle, is that you create light. Now, the heat it creates is considered to be waste energy because it's not the aim of the bulb. So looking at this picture, you can see that this is the chemical potential energy being produced. And it splits up into light energy and heat energy. So half of the energy that is being turned into heat energy is lost because you want the light energy, you don't really want the heat energy. If you're feeling cold, you don't exactly light a candle. So the heat energy is wasted. Another example of conservation of energy. This is stretching a bow is an example. So we get energy. So let me start from the beginning. To stretch the elastic of a bow, we need energy. Now, we get this energy from the food that we eat, which is called, if you remember, chemical energy. So when we eat, chemical energy is created. Now, when we stretch the bow, chemical energy is changed into elastic potential stored energy. So remember when we talked about elastic potential energy? So we're changing the energy we gain from the food to elastic energy to pull the bow. So when the elastic is released, so when you let go of the bow and shoot the arrow, energy is changed into kinetic energy and the arrow flies off. So you're seeing how the chemical changes from one state, you can call it, to another. First is chemical energy from the food we eat. Then that chemical energy is changed into elastic potential energy when we pull the bow. Then that stored energy from the bow, when you release the elastic, energy is changed into kinetic energy because then the arrow flies off, so it's moving. So that is kinetic energy. So you see how it changes from one energy state to another. Moving on to the topic of work, which is very much related to energy. So work is when we move an object, we move any object. So for example, when a man lifts a brick, you this is an example of work. So if a man exerts an upward force to lift a brick and the brick move upwards, work is done. Now, if you, for example, push against a wall, is this work or not? Think a bit. Is anything moving? Well, the wall doesn't move when you push it, so that is not work. Now, to calculate work done, you have to times the force of the force that you use. So, for example, if you're picking up a brick, you use a force of, you use a force of 20 newtons, for example, and the distance you picked up. So, from the floor when you picked up the brick to when you're standing up with the brick, how much force, what was the distance? So, for example, Mary takes her baby daughter to the park. Mary pushes the pram with a force of 80 newtons along a distance of 100 meters. What is the work done by Mary? So we know that work done is the force times the distance. So over here it's saying Mary pushes the pram with a force of 80 newtons along a distance of 100 meters. So you have your force and you have your distance. So you do 80 times 100. In this case, it would be 8,000. So work done. Oh, I forgot to mention. The unit of work is joules, J. Don't ask me why, I have no idea. Newtons is N, and meters is M. So work is joules, force is newtons, and distance is meters. So in this case, it's 8,000 joules, because you do 80 times 100. Moving on to energy and work. Energy is the ability to do work. So the amount of work that is done, the amount of work that we do, so work, remember, refers to picking up an object, for example. The amount of work that is done tells us how much energy has been converted from one form to another. So what this means is, sorry. So what this means is when you change chemical energy into kinetic energy to move the object, uh, how much is that energy? How much energy was changed, kind of. So let me give you a better example. Pulling the bow and you're stretching the bow with the arrow. When you release the bow, you're changing you're changing elastic energy into kinetic energy when the bow flies out. Now, the amount of work done, how much of that energy was converted from the elastic energy to the kinetic energy. So, another example, working against gravity. Work done equals energy changed. So the amount of energy that is changed is equal to the work done. So, for example, gravity is always pulling downwards. So in order to lift something up, you must work against gravity. So, for example, to pick up your phone, gravity is pushing it down, but you're working against gravity to pick it up, kind of. As we have seen previously, when the man lifted the brick to the shelf, his work was 100 joules. This means that 100 joules of chemical energy, which was the food that he ate, was converted into 100 joules of gravitational potential energy. So, the chemical energy is changing into gravitational potential energy. And further, 100 joules of chemical energy, which you got from the food, was changed into 100 joules of gravitational potential energy. You see, the amount stays the same, it's still 100, but the type of energy changes is changing from chemical to gravitational. So continuing, falling under gravity. When something falls from a high place, all its potential energy is converted into kinetic energy. So when you drop, I don't know, your phone, for example, it's changing from potential energy when it's in your hand, because we said there's gravitational potential energy, which means there's gravity pulling the phone down to the floor. And then it's converted into kinetic energy when you drop it, because it's moving. Now let's look at this example. Actually, I'm going to stop the video here, and I'm going to be uploading a part 2 to this video. So go through this video and then I will continue.